Okay, in this problem, we're actually going to construct our first confidence interval around a mean, and I think you're going to actually discover that it's easier than the proportion one. So here we go. We have a bunch of newborn girls, and we weighed all of them, probably for nutrition reasons, to see maybe at a hospital if everything's going okay. So we have 246 measurements. Of that, we have 33.3 that was their average weight with a standard deviation of 6.8. In chapter 3, I taught you how to calculate all these numbers. For now, they're just going to calculate them for us, which is really nice of them. So with these numbers, we're going to go ahead and construct a 90% confidence interval. Okay, so as I told you in the previous video, there are two formulas to use. You either use this formula with the Greek letter sigma if you know the population standard deviation, or you use this formula if you do not know the population standard deviation. So to tell which one to use, you need to read the problem and see if they give you the population standard deviation. Now, in real life, we almost never know the population standard deviation. That's why we're doing statistics. But sometimes these problems might give it to us. So if you read this very carefully, you'll notice that they do not give us the population standard deviation. And so that means we're going to use this unknown formula down here. And I'm going to write it down below right here. It's x bar minus, this is the unknown formula, t alpha over 2 s over the square root of n is less than mu is less than x bar plus t alpha over 2 s over the square root of n. There's our formula for our confidence interval. Now, you'll notice that our critical value has changed. It's no longer a z critical value. And so what that means is that we're not going to be able to use my nice little z table. Instead, we're going to use what's called a t-table to build this confidence interval. Okay, so we're going to use a t-table, and the t-table is just like the z-table, it's just a little bit bigger. Okay, here we go. So let's just write down all the values we know. We know x bar is equal to 33.3. We know that S is equal to 6.8. And we know that N, our sample size, was 246. So all those numbers I just got from the problem. That means we need T alpha over 2. And we need one other thing called DF. Okay. When we're doing a t statistic, we need to know one thing called degrees of freedom. Now, what degrees of freedom are is a little bit beyond the scope of this class, but it's basically how we make our statistics be less biased. The point is that degrees of freedom is almost always n minus 1. It's almost always just your sample size minus 1. Not always, I will tell you when it's different, but your default is degrees of freedom is n minus 1. So in this case, degrees of freedom is 246 minus 1, which is 245. Okay, that number we will need in order to do our to find our t statistic. Okay, so df, when you're working with t, you need degrees of freedom, which is just n minus 1, and in this case 245. Okay, let's find our t critical value. And so to do that, we are going to use what's called a t-table. And I have a t-table for us. Before we do that, remember, we're doing a 90% confidence level. 90% confidence level. Also remember that all confidence intervals are two-tail, and we'll talk more about that in chapter 8. So two-tail 90% with 245 degrees of freedom. Here is what the t-table looks like. I have uploaded it to D2L for you. I'm going to see if I can download this so I can zoom in. Okay, so here's our t-table. Now you'll notice down below I've added these two columns to make things nice for us. Bold values are more common. So you can see here I have my t-table. So if you remember, we were doing two-tail because all confidence intervals are two-tail. So two-tail 90% And so we're going to be looking at this column right here. You can also look at the alpha values up here, which we'll talk about later. So 2-tail, 90%. So we're looking at this column right here. And on the left, you see it says DF, which stands for degrees of freedom. Now, if you look at your notes, we had 245 degrees of freedom. So we just go to the closest number that is closest to 245, which is 100. So we go from 100 over to 90% two-tail. 90% two-tail, 100 is 1.66. That number right there. Remember, these are all kind of like standard deviations. That's what these really are in the end. So two-tail confidence, 90%, 100 is the closest to our value, gives us 1.66. So I come back to my notes and I write 1.66. Easy as that. I now have all of the values and I can go ahead and just plug them in to the formula to build our confidence interval. And it's actually, the formula is a little easier than the proportion one. So let's do it. So it's 33.3 minus 1.66 times 6.8 divided by the square root of 246. Now this time only the denominator is in the square root, okay? Only the denominator is in the square root. Is less than mu, is less than our average 33.3 plus our t-statistic 1.66 times standard deviation of 6.8 divided by the square root of 246. There you go. There's all the numbers plugged in, and so now it's just a matter of doing it on our calculator. So 33.3 minus 1.66 times 6.8 divided by the square root of 246. So be really careful with your order of operations when you're doing this. In fact, it might even be better to not put it all in the calculator all at once. But in any case, 33.3 minus 1.66 times 6.8 divided by square root of 246. The s is on top, so it's timesing. The denominator's on the bottom, so it's dividing. I hit enter, and I get an answer of 32.58. The answer that the book was looking for was 32.6. So if I round it to one decimal place, I get 32.6, which is the answer that they were looking for. And it'll tell you how it wants you to round in the homework. Nice thing about plugging it all in at once is that I can move to the right or move to the left, hit second left to get to the left. Just replace the minus with a plus, and you get the whole right side of this. So if I do that, I get 34.01, and if I round that to one decimal place, I get my answer, 34.0. So the confidence interval answer is 32.6 is less than mu is less than 34. We're 90% confident that this confidence interval captured the true value. Okay? That's it. That's how you construct the confidence interval. Let's answer this last question. Are the results between the two confidence intervals very different? So here's our confidence interval that we found. Here's another confidence interval that they found with only 12 sample values of 32.5 to 34.9. And so I would say that these two confidence intervals are pretty similar. 32.6 is really close to 32.5. 34 is really close to 34.9. So, I mean, this is kind of a judgment call, but I would say that they're pretty similar. The results are not very different because the confidence interval limits are very similar. I mean, that's kind of a subjective question. I care much more about did you get the right answer up here than if you answer this one correctly. So let's talk about the t-statistic one more time. You notice that this person did a sample with only 12 people instead of 246 and got about the same result. How is that possible? The reason is thanks to the t-statistic, because what you'll notice is that the t-statistic enables us to have a really small sample size. Look how small we can make the sample size. And notice that we get penalized pretty heavily for having a small sample size. These numbers get pretty big which means that our confidence interval will get wider and wider and wider if we have a small sample size. But what's nice is you can do a sample size using the t-statistic even with only a smaller sample size and still get results that are statistically significant. So that's why this t-table exists. You notice that as the sample size gets smaller, the critical values get bigger, which penalize us and make our confidence intervals more wide and less useful, but they are still statistically significant. And in this case, you saw how a sample size with 246 people was similar to a sample size with only 12 people, and how that could be allowed. Please let me know if you have questions. I promise this gets easier the more you practice it, and I will see you in the next video for another example.